Morning, Observatory fans. Well, I've got a treat for you guys this morning. We are going to do some proper science experiments. We're going to use the scientific method to measure something, to time something, right? So I hope you enjoy this. I had some Dunning-Kruger comments this morning, so I thought we'd just get an accurate definition of what Dunning-Kruger is. So before we go and do the science, Alexa, what does Dunning-Kruger mean?
Here's something I found on Dictionary. Dunning-Kruger effect is a proper noun meaning a cognitive bias by which an unskilled individual suffers from illusory superiority, mistakenly rating his/her ability as much higher than it actually is.
Right. Now, see, I never really claimed that I'm extra clever, but it's my levels of common sense I think are noteworthy, obviously, because most of this is about common sense. All right, folks. So now let's cut to the chase. Let's stop being silly. I've made a checklist. All right. Checklist of things that we're gonna observe. So let's go out here. Today's experiment, it's all going to be about the sun. Okay. So as you know, your sun is at a distance of 150 million kilometers from where we are, and it is said that the sunlight travels at 299,792 kilometers per second, or 299,792,458 meters per second. There is no actual workings out or a calculation that shows how that was broken down, but for some reason it doesn't seem to bother any of you. You've got excuses for this absence of the equation. Excuses like, everybody knows it's been worked out, or we have loads of technologies that today run off of the speed of light, so it must be right. And how would the GPS work otherwise? Yada, yada, yada. I don't think any excuse is good enough for the lack of a equation that clearly shows a breakdown of how something that is obviously impossible to measure is enough. But if you think that the excuses that are given for the lack of the equation that proves they've measured the impossible, then maybe that is just a lack of common sense on your part. So what we're going to do today, I've got a checklist. One, does it look like the sun is in another place because of the 8:20? Is it obvious that the sun takes 8 minutes and 20 seconds to reach Earth? How long does it take our eyesight to reach the sun? Does it seem logical for the sun to take 4.6 seconds to radiate its own light, the distance on its own diameter? Same for the 8:20. Is it logical for it to take 8:20 to reach here? And what do various experiments show? Right, so let's look at this one by one. Does it look like the sun is in another place? When we look up at the sun, when we look up at the sky, okay? Now, here we go. 1, 2, 3. Does it somehow look like the sun isn't there? Does it look like it could be somewhere else? Well, listen, I don't know what it would look like if the sun was somewhere else, but it was really there. Or vice versa. I don't know what it would look like if it was there, but supposed to be somewhere else. But my common sense tells me that the sun is exactly where it seems to be in the sky. Just one more look, it's good to double check these things. So, what we're looking for is a sign that the sun isn't there. All right, we're looking for a sign that the sun is already 8 minutes and 20 seconds further away on its journey. Now, listen, I look at this again and again, and I'm going to have to say, just siding with common sense, okay, that the sun is exactly where it seems to be in the sky. My common sense tells me it is, okay? The fact that so many people think that you're looking at an 8-minute, 20-year-old sun is... Anyway, that's not about that today. Is it obvious that the sun takes 8 minutes and 20 seconds to reach planet Earth? Okay, now how would we do this? Well, I suppose it's along the same lines of if we think the sun, if it's not there, is it there? Is it there? Is it not there? It seems to be there, but it could be 8 minutes and 20 seconds further away. If there was a sign, if we could somehow physically see, that the sun was actually over here, even though we're looking at it and it's here, but it's very difficult, isn't it? It almost defies logic and common sense. It's nearly as if somebody would have to be just a little bit silly to believe that, isn't it? Should we take one more look? Remember, when we look up at that sun, it isn't there. It's already 8 minutes and 20 seconds somewhere else, because that's how long it takes for the sunlight to reach us. So let's take one more peek. Let's see if we can surprise it. No, it still looks exactly like the sun is where it is, doesn't it? It really does. So again, I'm thinking that for me to believe that that sun is not there where it seems to be, I would have to seriously slash some of my common sense, and I refuse to do that for something that there is no actual equation that it has been worked out. But y'all do what you need to do, okay? The fact that 2 atomic clocks were out by 300 billionths of a second in 1971 is reason enough for you guys to believe that the sun is actually 8 minutes and 20 seconds further away than where it seems to be, okay? But I'll be a bit blunt. I don't think I'm stupid enough to believe that, all right? Number 3, how long does it take our eyesight to reach the sun? Now, there's all this Mickey Mouse-ness going on, isn't it? Our eyesight takes this long to do. Well, I say that our eyesight travels at the exact speed of the sun's light. It's absolute. How do we prove that? Well, all we have to do, you know, this, well, they tell us that the sun is 150 million kilometers away. So when we go like this, bang, look, our eyesight has just reached 150 million kilometers. Unless, of course, we're looking at a sun that's 8 minutes and 20 seconds old. But even so, we're still traveling 150 million kilometers with our eyesight, aren't we? Whether it's an old sun or a new sun, we are still seeing 150 million kilometers away. So, of course, our eyesight is absolute. There is no distance. There is no distance that our eyesight won't reach in the night sky if there is a light bright enough, okay? The only reason we only see a certain amount of stars in the night sky is because there is only a certain amount of power, of luminosity in those stars. If a star appeared that was more luminous, brighter, bigger, then we would see that one as the furthest star away, because it would be more powerful and it would radiate its light further at absolute speed. Number 4, does it seem logical for the sun to take 4.6 seconds to radiate its own light the distance of its own diameter? Does it seem logical that it takes the sun 4.6 seconds to radiate its own light the distance of its own diameter? I'm not even going to go anywhere near that, because it's obviously no. It isn't logical for any sphere to take 4.6 seconds to radiate its own light the distance of its own diameter. And if we go up to the size of UY Scuti at 2.377 billion kilometers in diameter, it takes it 2 hours and 12 minutes to radiate its own light the distance of its own diameter. People, this is about common sense, right? It really is. So I'm sorry about that. Same for the 8:20 to reach Earth. Is it logical that the sun would take 8 minutes and 20 seconds to reach Earth? Yeah, it's logical if you lived in the twilight zone or if you've been lobotomized at birth. But look, no, it's obviously in the sky where it seems to be. The sun is radiating onto planet Earth. And the last question is, what do various experiments, visual experiments, tell us about the speed of light? Let's have a look, shall we? Well, I can see the light shining on the grass, on that table, on the shed, on the trees at any time. Does it look like it's 8 minutes and 20 seconds old? That would mean that that sun that is clearly radiating absolute light would be somewhere else. And just so that you know I'm not cheating, it is the real sun, because look, we've got it bouncing off of a mirror as well. So as you can see, there is no doubt the sun is shining on the roof of my house, on the roof of the neighbour's house, on the neighbour's antenna, on that neighbour's antenna. Holy smokes. I was going to say oh yeah, it is. Look, it's shining on our antenna, on everyone's antenna, and all of the trees around us. Look, it's all sunlight. Does it look like it's 8 minutes and 20 seconds old? No, it doesn't. So, why would I believe? Why on earth would I believe that it takes our star 8 minutes and 20 seconds for it to radiate its light to here? Only believing the illogical and leaving one's common sense at the door, that is the only reason anybody would be able to believe this absolute horseradish. But if you come up with an equation that clearly shows the breakdown of how 299,792,458 meters per second was worked out, it would be a different story. We know that you all make excuses up for that one, don't you? For 2 years now, nobody has had the to say the reason that there isn't a calculation is because it hasn't been worked out. Well, I'm telling you now that the reason there is no calculation for the speed of light, there is no breakdown of how it was done, how many times the mirror was spun and what that signified, why one beam of light went off to the left and what that signified in the speed of things. It's a load of horseradish. And you people are believing stuff with no evidence. So don't tell me it's me suffering from Dunning-Kruger. Admit to yourselves that you have limited common sense because you believe absurdities that there is no evidence for. All right? So that'll be today's science. Look. Look. It really does look like it's there in the sky, doesn't it? It doesn't look like it's 8 minutes and 20 seconds ago, does it? Ridiculous claims. All right, peeps. How long did that take? 12 minutes of pure science. Wow, awesome. Later, peeps.